recording. So I've started the recording. This is Design 301. It's our lecture and practice. I'm on the wrong day here. Sorry about that. Let me get over to here. It's Thursday, June 24th, and we're just going to talk about drawing standards and what makes a good drawing. And that's really what we're up to today. And this is one of the last plates in your template for this week. And as I was saying, next week you're going to get a chance to draw a whole bunch of different stuff, and this is to help you kind of get ready in week 5 and 6. Each week you get to focus on a project of your choice. Now I give you the project so that you don't have to make it up, but you can just start drawing landscape or design or something like that. I did want to show, there were some really, on the patterns, I really enjoyed, Noor put in a really nice, look at how nice that looks. That, just the color choice and everything just looks really good with that one. And then I told you that I would kind of show how to do masking. So this is what you see here is the pattern that I did, and then I just copy, array, and then I made a polyline that I could make a viewport of. So this is all sitting essentially behind the viewport mask, and it's kind of neato. So I'll make a video on how I did that in case you're interested. So that's something you could do if you are into graphic design. Then in week 5 you can create some nice graphic design templates for you to use. But for right now, let's take a look and see. The first thing I want you to do, we used to have this on our website, and then the district in their wonderful decision made us all look alike. So this is no longer just available to you, but we have our own website, and you can look at our sim tools and tutorials and videos and stuff. But we have a student showcase, and every year or two we update these. Kimiko, Kiki, is now the BIM director for not Knockton Lewis. Darn it, I'm blanking on the name of the structural company in Southern California. So he's our BIM director. Catherine is the data director for the wastewater treatment plant, the big $25 billion improvement going on at wastewater treatment plant Sac Regional. Thelbert is now working with a structural engineer in Hawaii. Katerina is with Caltrans, and Mark Westbrook basically works on his own. He's actually a semi-professional crew guy, and so when crew season is not in season, he farms himself out to do design work. And so as you're looking just at good solid drawings, these are great ones. You can just look at these, and you can also look at our program's examples. Here is just a whole bunch of 2D CAD things that you will see that were drawn in by students in our program. So here's a mechanical detail. Here's just a planning visualization. Here's a site plan with a section view, a section with details. Here's a topo view. Here's a lot plan. Here's a mechanical detail, another mechanical detail, another mechanical detail. So you can see in our program, you have an opportunity to do a lot of different types of drawings, and you can look at these and you can kind of pick them apart and just talk about them a little bit. What makes this a good professional style drawing? There's good line weights. There's these are all in good positions. There's standard tolerances. Tells you how much it's made from. It gives you a nice visual. This is a little sloppy right here, but it's still pretty professional. These are all coming off between 15 and 75 degrees. That's an important thing. Special tolerances are on there. There's notes. So these over here, this should have really had a break so that was really a center mark. So this section line went over the center mark line, and that is not really symmetrical with that. So this should have, what should have happened is that this section line was broken between here and here. When it's obvious like this section line should be broken here and here. Now, look, this is actually a pretty darn good drawing. Overall, it's a really good drawing. But there's just little, what's that? Yeah, right here. Yeah, and that could be the, because this is actually made out of a solid model. So that's probably just the bad plot. I'm gonna guess. Could be. This one's pretty nice. This is pretty nice, showing the offset thing. But often this little line and this little line are not shown. But these are pretty nice little details, mechanical details. Here we go with some of those. This is a section. This is a detail. These are more civil details. So just different types of details. And this is a typical detail page. This one's really a pretty nice drawing right here, where there's a concrete footing, but there's an alternate. So that's something that you should know about, that often happens. Maria is working for the state architect's office, the Office of State Architecture right now. She came to us with a graphic arts degree from one of the Eastern European countries and wanted to do more technical work. And so she was with us only about 1 year. And because she had a degree and got some skills and started working. Here's a very typical, now this one is not done right. This is not correct. You are not allowed really to just take a snip from Google Maps. This should have been traced. But Alex was really cool. She came to us as so Catherine, by the way, was she had her bachelor's degree in mathematics from UC Davis and didn't know what she wanted to do. Took a class from us, loved it, got her certificate in about a year and a half, and just loved this stuff. Alex was actually a degreed engineer from, one of the Harvey Mudd. And she couldn't find a job because she had no technical skills. And so she worked with us for 1 semester and got a great job with Kleinfelder, doing civil engineering and drafting and stuff like that. And I think that she is now, that was about 5 years ago. So she is very, very close now to getting her civil stamp. But this is a very nice section of a survey section. So that's a nice one. Here's another one where there's a site plan and a section, and you'll often see data and things like that on a drawing. This one is very typical where there's a series of sections. So this was a project that I worked on in my professional career, Highway 118 and First Street in Simi Valley, and we did the irrigation system for it. They were trying a new style of irrigation system that the company that I worked for had developed. So this was a Caltrans project, and they opted to use our system as a trial. So they let us use their solid model, and we use that to develop things from. So this is an actual real Caltrans, from a Caltrans development. And this one is okay, but the it really shouldn't show the border in the border, but it's close, very, very close to a good professional drawing. This is very typical of how a lot would be set out, and then the actual data from it. You know, and this is really interesting because lot plans are the basis for tons of work. So when a civil engineer creates a lot plan or a plot plan, they have to know how much power to drive to bury, how much water to bury, and how much drainage to bury, to name a few. And those are all built on the building pad, which is all designed on whatever the building code is in that area for the maximum amount of built out area for a lot. So this is showing how from the lot line you can develop this, and this was all done in Revit. So once this was developed, this all comes from it. You can do calculations based on those things. So this was a cool one. Alex did another nice job on a lot of these. So here is, again, you can see it was the same thing. And this is just showing where the architect now is going to be given this and say, okay, here are your lots. Now, you get these building pads and go to town with it. And now you can see some drainage. So obviously, when a property gets approved or a development gets approved, you have to make sure that you're not ruining the existing drainage around. So since these ones are going off-site in this direction, the planning department would either require a mitigation along this lot line, something like a swale or a French drain, or they would ensure that this property owner will accept this amount of drainage coming off of the property. And since there's a percent permeability of this ground, so that all comes from geotechnical work, it could be that this drainage doesn't really affect. So I'll tell you, drawings are the basis of all the stuff that gets done, and doing the drawings is cool, but to me, all this problem solving is what's cool. I'm an engineer. I love to learn about this stuff and know about it. And I don't really get into this stuff a lot. Mostly in my life, I had to do with the pumps that did take water away, or did take sewage away, or did pump clean water up to the second, third, or fourth floor. So I was always around these drawings, but I was never really on these in my professional career. But I love them. Here's the Simi Valley Overcrossing again. This is a really nice drawing, by the way. This is really, really nicely done. That was Maria again. That's probably why she got a job with the state architect's office. Some mechanical details. This was my life too. This was actually a pump shaft from one of the pieces of equipment, rotojet pump, that I made, that I worked on. It was really cool. The rotor that would go on this weighed up to 150 pounds and spun up to 10,000 RPM. So you don't think we had some cool bearings on here and some really good balancing. Before we inherited this product, they did have one disaster in Huntington Beach where one of these threw the pump rotor about 2 miles. It went up in the air, it vibrated and threw it. Fortunately, it landed in the ocean. This was a really cool product. And this is just sort of just to show the cool stuff that can happen. This was Alex again. Here was a bearing housing for another pump. This is showing just some collaboration work, how you put a drawing set together. This is a very typical mechanical room design showing the layout of a building and showing some HVAC and how that would happen and some mechanical work. All of these people had a different part. So even though this person was putting a full set together, Alex was using Carter's work to import his work into her set. So just some more nice work. This one is taking a section of somebody else's work and doing some inspection work. Disc assembly. Let's see. This one's a nice job of taking somebody else's model and creating the details from it. So these are all the different section views and details that are needed to be able to make this product. This was another product that I worked on. This comes from my background. This is a part of a diaphragm actuated pressure reducing valve, and normally this piece is all separated, but because some of these pieces are brass, they would just cut this off and run and sell it for $1.50, and thousands of gallons of water would just go out on the ground. So this was our version of integrating that all into one. So those are just some kind of cool, isn't that neat? Those are all the types of drawings that you might draw in ours, and you can look at those and say, okay, I can identify this, I can identify that, just for fun. Here's just also what you can do in our program as 3D modeling. Those of you who like interior design, this is part of the interior design that you can do. Reworking existing campuses. Have a question, Stephen? Yeah. Yeah. Let's see. That was that one. That one, right? Yes. Yeah. So look, civil people put them everywhere. They don't really care, and so this person chose to make it as large as they could, and you'll even see that this scale is different than this scale. And civil people do that all the time too. This thing, if you were to really walk it, isn't nearly that steep like that. Yeah. Oh yeah. Yeah, but even still, this is this and this. That's many places would have made this one a little smaller and put this one big across the bottom. But Alex chose to really highlight this one to show this drainage and where this would go. So this is very typical. Civil people, they have no rhyme or reason for scale and for where things go. Like me as a mechanical person, I would have projected it up here, right? Because this is the cut line, right? But civil people just know in their brain. They go, oh, that's what that looks like right there. And they've made it really steep because they want to show me something. So that's what they do. That's how they do it. Because if you look here, this scale is not the same as this scale. From here to here is 50 feet, and from here to here is 10 feet. So the scales are way different. Interesting, huh? But it's a good standardized detail. The only thing I'd say is they need to adjust this line weight a little bit. That one's a little bit kind of clunky. And it would be good if they had put a line break on these or moved them to one side. But pretty darn good. This is like pretty good. This is actually a B size. Yeah, it's a B size. That in this particular class, when I teach the class, which is why I have these, the whole portfolio is 11 by 17. So they make all of these and then they have to rescale them to fit on an 11 by 17. So that's where that one came from. And then they have to make it fit on a portfolio. So this is the portfolio title block. And this is the actual drawing right there. So that's why it looks a little bit funny. This is showing how to take some basic tech specs and create 3D models and make them look cool. You can do this in AutoCAD. This was all done in AutoCAD. Kind of cool. Some more cool stuff. How to use colors and how to use renderings and how to do cool stuff to make things happen. How to, show where this was actually done by an HVAC professional who wanted to learn how to use some Revit. And so this one, the person took the Revit. This was an actual job the person was working on. And so they did, this one's a pretty professional job. But more cool modeling that you can do. SketchUp. You can do some pretty darn nice stuff in SketchUp. It's pretty good what you can do. That's a nice bit of modeling right there. That's a beautiful piece of modeling. Here's some nice work that was done for a building renovation on campus. Never got done, but that was part of it. Just, kind of cool. This is not really the stuff you're supposed to be looking at now, but it's kind of fun. So you can feel free to look at those, or you can look at the portfolio work that eventually got done. Let me get rid of this one so you can see it a little bit better. This was Kamiko's just general online portfolio for his machine system work, and you can see, modeling, calculations, fixture drawings, details, flat plate layouts. I don't remember what type. This looks like a detailed drawing again. System drawings. So you can feel free to get on here and just get, tech docs types of drawings that are done. And you can look at these. These are land planning drawings, survey drawings. This was survey drawings. All you get are the thumbnails from what he gave us. his site had, these would all link to the full drawings. But for what you need in ours, right, you can get big enough and pull it. Oops, let's see. I'll get rid of that. Bank. These ones, a lot of those drawings you'll actually see in here. Some of those at least you'll see. But if you're interested in just seeing some of them, this was a portfolio from Design 310. And she was a math major, so she loved all the analytical stuff that you could do. You know, here's stuff that you could actually design by parameters and Fibonacci's rule of 3, gear stuff that you could do, braking stuff and analysis, cooling analysis. She just loved analysis. And so she made a very nice presentation. There's a little bit of vector work, doing some very simple 2D finite element analysis to get loads. So if some of you are going, don't worry about it. It's okay. This was just a person's just love of doing this stuff. And so that's what they focused on. This was a design. This was the first drone that we built. We flew this drone at graduation in 2018 graduation. So that was kind of cool. We actually flew the drone, fit it with cameras, and streamed it during graduation, all done by students. So there's just some more cool stuff. So you can look at all of these and just see kind of what people have done. The other thing, if you feel like it, you can just go look at keywords. So let me do architectural roof plan and see what we can find. Well, there we go. So now you can look at lots of different types of roof plans. So this one is a rafter plan or a roof framing plan that shows where the rafters will go. And it's very nice. It's got the visualization. It's got the plan view. It shows what the rafter structure will be like. Here's a detail that looks an awful lot like that one that we drew or that we looked at. A bunch more. So you can just get on here and look at some of these. Here's some more that you can look at. There might be others in here. There's a very typical one that's showing what the ridge lines look like and the valleys and the hips. These are called hips, ridge, valley. So you can just type that in and go, oh, I got it. Now I've got roof plan. Let me look at foundation plan. Oh, okay. Now I know what a foundation plan might look like. Okay, and a floor plan and elevations and truss drawings and interior elevations. So this, just by doing, oh, is that a lighting? An electrical plan. There's details. There's a very common detail sheet. Okay, so this is cool. This, like, by typing that in, you can get a lot of, real quick idea of what some of those might look like. What else could I type in? Mechanical. I'm going to say mechanical bearing frame assembly. Let's just see if I find anything. Maybe I'll put drawing in. Oh, there we go. There's a bearing frame of drawing. It's showing how the bearings fit. Here's another one. Let's see if I can find. A lot of times people don't put real ones on here because they don't want to give up their information, right? But that's a very good assembly drawing. So there's a pump assembly drawing. And I used to work for a company that made these. So there's the impeller, the inlet, the front plate, the frame, the back plate, the bearings, the impeller nut, bearing frame, bearings, shaft. All sorts of cool stuff. Many, many groovy, cool things. So you might put one of these on. Let's see if there's any bearing frame assembly drawing. Maybe we could do a just for fun. Let's see what some of these other keywords are. And here's some extra ones in case you're trying to see. This was a project that was done, and I'm not showing Dan Taylor's. We'll show that one in another one. Here's David's. Dan won a Golden Bear Best of Show in 2016. He did a full design 3D print, made a working model, and designed a facility that would do this. But this is a pump assembly. It's a piston pump. And you can see here's the piston. Here's some housings. Here's a housing. Here's some cylinders. And you can see that he did a very nice job of putting this together. This was from the Design 330 class. And David works at the same company as Kamiko. That company, Bueller, that's what it is, Bueller Engineering. Their BIM manager graduated from our program when she was 16 years old, and she is their BIM manager now. And so people go and interview, and she's like 31 or 32. She's got 15 years of experience, and people go, no, we were looking for an old person. She goes, no. And so she loves taking our people. If you're into structural drawing, so David works there. A bunch of people work there from our program or have worked there and have gone on to start their own. So there's another one. Here's a detailed drawing. Oh, this is a MEP, mechanical, electrical, plumbing. So there's a typical space plan. There's a little bit of a volume work, some mechanical HVAC layout. It shows what it looks like. So it's Leah. Here's some electrical. Again, just showing some basic simple work and some layout and where certain things would go. Some lighting layout. And this is some of the plumbing run. Pretty standardized, simple stuff. So that's another type of mechanical. Let's look at footing detail. tons of footing detail drawings. Sorry about that. Dogs are freaking out. Let me close the door. There we go. I'll only get some of their sound. And so here's some more that you can look at. So those are very, very typical. So you should be able to find plenty of drawings that you can use in the week 3. Let me get back here and find my week 3. So when we get down to here, you should be able to find mechanical detail or mechanical assembly, architectural plan, architectural elevation. Let's look at a civil topo. Well, there they are. Those are very typical civil topo drawings. There's a typical there's a typical topo drawing. There's another good one. That's not a topo drawing, but it's a site plan or a plot plan. Yes, there's a ton of them. Really what they do is they turn them into a point cloud. And so Revit can do that. Architectural CAD, AutoCAD, Civil 3D. AutoCAD can actually do it. And yeah, the excavators just now just go out and dig and yep. Yep. Yeah. Yeah, when you really know how to do it, and like here's a typical one. And we've been lucky. We did a really cool job for there's a real that's a super common one. You would see there's another one. Here's another real common one. If I look up, let me look up Wildman Hill. These are all drone data exports. So this would be typical. This was taken from a drone flight that we did, and we've done a number of them. And this was just a drone flight that went directly into Revit. And from Revit, we could place the road, do some excavation, look at how we would take this site and develop it for an existing or for a new construction property. So drones are really great because they give you XYZ, XYZ RGB. They give you all sorts of different formats of these point clouds. And we can even get, this was a DXF of an elevation topo. We didn't even have to worry about points. We got the topo drawing from a drone. And then, of course, you can just plug that in. So it's really, really cool what you can do. Let me look at... we did a really cool one for Piner. This was a job that we did for an architect. And no, that's not what I need. I want to get the output if I can get it. See what we get off. I think these were our original files, exported files from drone deploy. And here's condition files. So here you can see we can get all of these. We can get a KML, a TIFF, a DXF, a JPEG, an LAS file. Those are all different file types that are used by different programs to import the data for use of machine tools or whatever. But this DXF is really cool. Maybe I'll try to remember to get set up to show you how that goes right into AutoCAD. And we can just start working with it. Let me, I'll try to remember that for our highlights. Okay, cool. So yeah, they just talk now. They talk to the excavators. Really, really cool stuff. So what's the purpose of this? The purpose of this one is for you to just look at good drawings and show them. Okay, do the best you can to find something that looks professional, looks well done, and present it. That's our goal. Do you know what a good drawing is? And so we've gone over lots of good drawings. If you get one off of here, those are pretty well done drawings. If you get one off of our program examples, those are pretty good drawings. And you can look down here. Here's just good. Here's some of the. This is the one that Dan did. This was his project. He did this in Design 330. Of course, he spent a little extra time. You can just find good drawings. Good detailed drawings. This one is interesting. This is an inspection drawing telling you how to inspect and how much to inspect of different things. That's a cool drawing right there. So there's the inspection drawings. Here's the fixture drawings. He did such an outstanding job. Here's the bills of materials, component workflow. What are these ones? This was his planning document for his cost estimate and 3D printing this whole thing. Pretty cool. That was pretty cool. No, just putting it in, just saying, hey, here's a good one, and just saying what it is. Here's a civil elevation. Here's a civil plot plan. Here's this is a closure of a traverse. That one's really cool. How do you close a traverse? There's a bunch of those. Here's a topo drawing. There's a really nice one. Here's a site elevation from a topo. This was a cool one. How do you know how to take your plane off to miss this mountain when you're not going right at it? You're going at a weird angle. That's a really fun one. How do you know where to put the sewer so it intersects directly? Oh man, we have some really cool stuff in our program. Okay, the idea is really, can you find 1, 2, 3, 4, 5, 6 drawings that look good and identify those as nice drawings? That's all it is. Cool? But I think it's fun. It's, cool to look at drawings. And then next week, you're going to get a chance to make drawings. Finally, you're going to make stuff. Last 3 weeks are doing drawings. Next week, I'll tell you exactly what to draw. The following week, you'll pick a project and do the drawings for it. Cool? All right. I'm going to go ahead and stop the recording.